Hello, Brandon.
Hello.
How are you tonight?
Doing good. What about yourself?
Just fine. Have you managed to find the driver you asked about?
Yeah, so it wasn't an issue with the driver I had. I just couldn't get Model Sim Altera to work. I figured it out. I just had to download and run it like separately.
Okay, so it is not a driver issue.
Yeah, I already figured it out, but yeah, correct.
And now you can download the program to the FPGA, correct?
Yeah, the issue I had was with running the test benches, but yeah.
Okay, thank you, sir. Hello, Joe.
Hi, how's it going?
Yes, are you ready?
Ready for what? I'm ready for for class.
Ready for class?
Yeah.
Okay. We'll wait a couple of more minutes, waiting maybe more people will show up. Just we'll give them a couple of minutes.
Is this week 4, right? Are we gonna be going over like the week 4 lecture PowerPoint?
I cannot hear you well. Will you please repeat the question?
I said, are we going over the lecture 4 PowerPoint today?
Today we are gonna be exploring topic 4. Yes. Just a moment. Let me double check. No, topics week 3. Week 3.
Okay, thank you.
I think we may start now. This is the PowerPoint that we'll be using. Before going into our new topic, I am gonna just go over homework 2. In homework 2, we have the 4-bit shift register. Here, The first shift register will have the input of the module and Q output connected to the module output. Input clock and a reset to the module. The reset should be asynchronously reset. This will asynchronously reset all 4 D flip-flops. So we have 4 D flip-flops because we have 4-bit shift register. And we have our input going to D is the first one, and a clock and reset. Now, the main issue here, I want to shift the bits from shift register 1 to 2 to 3, and it will get out from the last one after 4 clock cycles. Let's look at this shift register. The main idea here, it is this AND sign. It is not AND, it is concatenate. Concatenate. I am concatenating, as you can see, here is the program. Reset clock D in, D out. And I have signal D flip-flop. This is standard logic 4, because I'm taking from one to the next one. What do we have in here? Process clock begin. If reset is high, then the DFF will be all 0. Else if that is not happening, now I have a rising edge. At this stage, what are we doing in here? Can you see? The D flip-flop, which is 4-bit, it is taking whatever the values here, and I am concatenating D in. What do you mean by this? Let's see. I have 4 bits. This is my DFF. This is DFF. This is 4-bit. And I have an input that is called D in. D in, I am concatenating it with D in. What is happening is when you do the concatenation, this D in will go into this bit. And this bit will move to the following one. And this one will be pushed one more time. Pushed one more time. Whatever is here is lost. After 4 clocks, this D in that came in now, it will be at the output, ready to go out. After I finish this process, D out, what will be my output? It is the last one. This is the last one, DFF 3. This will be my final output. So as you can see here, I am having serial in and serial out. Serial in and serial out. Any questions about this one?
I tried to do it in Quartus. I just looked up the.
I cannot hear anything. Your mic is making terrible echo.
Can you hear me better now? Can you hear me better now?
Do you have a quieter area you could go to?
Would you all mute? Yes. Who is now? Yes, Bart. Go ahead.
You can hear me now without echo. It's working. That's technology.
Can anyone understand what he's saying?
No,
We cannot understand you, sorry. Would you type it? Yeah, but we need this in VHDL. No, we need VHDL program, not a schematic. Okay, check to see if this is gonna work. But still, I need VHDL. Preset, this is for parallel in. This is the next one, not this assignment. The next assignment, it is for parallel loading. Let me share the screen. I have here reset only, not preset. Preset will be for the next one, but here I have serial in and serial out. And this is the code. Would you all please, if you haven't done your own code, please look at this and try it. I'll give you 10-15 minutes for this one. I stop sharing so anyone may share the screen. So. This one. No. Oh. Oh. No. No. So. No. 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 Selam. Selam.
Hey, Professor, I have a quick one for you.
Yes, sir.
Sorry, hold on, let me figure out how to get this to stream real quick.
Okay.
So I've got the PowerPoint up here, right?
Yeah.
And I was just reading the 4-bit shift register and it says asynchronous reset. So
Ye-
should the process also include reset?
Just a moment. It says asynchronous or synchronous.
Asynchronous.
Asynchronous, it should be included in the sensitivity list. You are correct.
Okay, I just wanted to double check. Thank you.
No, you are correct. But either way, I'll accept it. But what you are saying is the best. To have it on the sensitivity list.
I'm
Thank you.
sorry.
So are we doing test benches for these? Browser?
Since you did one test bench, from now on, you have the option either use test bench or waveform generator. Whatever
Okay.
you see fit, just use it.
Great.
So this is what I came up with. You can watch the bit shift through the signal. Also, if anybody's curious how to get the signal on the waveform editor, I can show you.
I can see it. It is being pushed. Yes. Excellent. Just a moment, just a moment. Okay, and whenever you have a reset, everything goes to zero. Excellent.
Right down here.
Hello, Eric. Are you available, Eric?
Let's try. Good evening.
Good evening. Have you got it run or not yet?
I am running it now.
Would you please share the screen?
Oh, what am I looking for? Screen. Two. Let's try that. Oops.
Okay.
Yeah, so it's shifting over and on reset, it goes back to 0.
Okay.
And my-
Where is the reset command?
Oh, in the waveform, right here.
Okay. And everything goes to 0 then.
Yep.
Excellent. Thank you. Brandon?
Thank you.
Would you please stop sharing, Eric?
I was looking for the button, yes.
Okay. Brandon? Hello, Paul? Paul? Taylor?
Hi.
Does it work?
Probably. I haven't gone that far.
Okay. Do you need more time?
I'm just trying to figure out, I got the, here, let me share my screen. Sorry if it's hard to see. So I think I got everything, but I'm missing the DFF portion.
There's a trick to it if you want to know it real quick.
Yeah,
So,
DFF,
right.
it is a signal, internal. Here
Right.
we are interested in the input and output. So the input and the output are clock, DIN, reset.
okay. Yeah, I just kind of wanted to see.
You want to see it?
Yeah.
Under reset, right click the white space,
Okay.
then insert node or bus, just like you would for the rest. Node finder.
But you had it already. You have all
The
of those.
DFF. Yeah, no, but if you go see where it says filter,
Yeah.
drop down that list, go to pre-synthesis registers.
Pre-synthesis.
Now relist. There you go.
Yes, to get
You
the signal.
drop that in.
Okay.
Okay.
Okay. Okay. Very good.
Good. Okay.
Perfect. Perfect. Thank you. I believe we may. Does anyone need any more time before I proceed to the next one? Okay. Our next part, it is number 2. This is a 16-bit register with load and shift. And instead of 4-bit, now I have 16-bit. When the load signal is asserted, the register should synchronously load the value of DIN. So I expect DIN, now it's not gonna be 1-bit. No, it's gonna be 16-bit. When shift is 1, I will start shifting those bit 15 should load 0, and whatever is in bit 15 will go to 14 and so on. So load will load 16-bit from DIN to my register. Then with shift, I will start shifting those. This is my program. This is my program, as you can see it in here. What do we have? Load. You can see here, D in 15 to 0, that's 16-bit. And the out also. And this is my shift register, shift right. And with my clock rising edge, if I have load is high, whatever is on D in, the 16-bit on D in, will go to shift register. If shift is 1, shift register will concatenate 0 to SR 15 down to 1. Now I need your comments or whatever you have noticed about this. Joe? Hello, Joe? Kobe? Hello, Kobe?
What was your question?
I am asking about this one. Is it correct? Does it translate what is required? Can you read here? When the load signal is asserted, the register should synchronously load the value of the in. We did that. When shift is high, bit 15 would load 0 and bits and 14 to 0 will start taking whatever was there, assigned to 15 to 1. We have something between 15 and 1. Number 15 will be 0, but the rest will shift. 1 will go to 0, 2 will go to 1, 15 will go to 14. Would this do it?
Yeah, because it's replacing the first bit with 0 and moving the rest down.
Okay, let me ask you one more question. Just wait. Can you see this concatenate, this and sign?
Yeah.
I am having here DFF 2 to 0, down to 0. Concatenate D in. But in this one, I am concatenating 0 and shift register 15 to 1. What the difference between those two?
The and symbol. So one is having the concatenation happen afterwards.
Can you imagine here? I have this is 15, this is 0. And I'm concatenating what? 0. So I have here my outer 0, and it will be went in here. Then what will happen to whatever is in 15? It will go to 14. And so on. Can you see the direction of my arrows here and here?
Yeah.
Yeah, it's just shifting left to right or right to left.
Yes, shifting left, that is from the most significant bit 15 towards the least significant bit 0. But for this one, I am moving from the least significant bit to the most significant bit. This is left, right to left. That is exactly what is happening in here. In this example, I am giving D in, and D in is being pushed all the time. But in this example, I loaded the 16-bit with numbers. Now I am pushing 0 and clearing everything. After 16 clock cycle, everything will be 0 because I'm concatenating 0. I don't have a stream of inputs. After 16, all will be 0 unless I load a new 16-bit. So this is parallel in, and you can call it serial out. Is it clear to you? Okay. Would you please start doing this? This is number 2 of our homework. This is number 2 in our homework. Go ahead, please. And I'll speak about the last one so I can let you work on both of them. Last one is 16-bit. This 16-bit, it is up-down counter. So I have it in here. Up-down counter. So I have here UD, up-down. This is an input. With this input, everything is the same as before. Of course, we have 16-bit. If up-down is high, I'm incrementing the counter. Else if it is up-down, it is not high, it will be 0. Now I am decrementing counter -1. So this is the difference between those two. I believe that is what we'll be doing tonight. So please work on those and I'm available. If those two works well with you, you may leave. If you don't have anything to ask about, you may leave. That is gonna be all what we are gonna be doing tonight. And hopefully we are gonna finish this topic on Saturday. So go ahead and work on 3 and 4. By the end of tonight, you can upload homework 2. How is it going, Cody?
8-bit counter seems to work fine. I'm just about done coding the 16-bit.
Okay, thank you.
I do have one really quick question.
Go ahead, please.
Okay, so in the actual code or in the example code, right?
Yeah,
Get this up my screen. In the process, there's an else for the counter decrementing. But I don't really like that because if the up down switch is undefined, then it'll decrement the counter. Is there any problem with me replacing that with an else if up down equals 0? It's this one right here. Because that way, if it's an undefined,
now let's go step by step. I have
Okay.
a rising edge and I have a reset.
Yep.
And else
counter
if,
goes to 0.
else if up down is high, then I will do this.
Mm-hmm.
Else if, why not else?
Because if that way, if the signal is ever undefined and not a high or a low, because I know the program will sometimes pick up the cross that
Because you have up down. Up down, it is either high or low. If it is not one,
if it's not one,
what
it's
could
0.
it be?
Like I get what you're saying. It just seems to me like, wouldn't it be better to ensure that it had to be low? That way you never get any unexpected behavior.
Oh, what you are saying, you are gonna speak about it in 2 weeks.
Okay, I used to do the software engineering program in C++,
Yeah.
so it's stuck in my head never to leave it undefined.
Yeah. No,
So-
this undefined, this is a huge issue that we'll speak about it in 2 or 3 weeks, not now.
Okay, but it would be okay for me to do this for this assignment.
I think it is not gonna make any difference.
Okay.
Else or else if will give the same results.
I'll test it and make sure there's nothing weird about it, but if there's not, I'll do it this way just because I like it better.
Okay, no problem.
Okay, well then I am all done for the evening. Thank you.
Thank you.
Have a good night.
See you Saturday. Bye-bye.
See you Saturday.